Hey everyone, welcome to the SQL Server on Linux course where we're going to tell you everything you need to know about SQL Server on Linux. I'm Travis Wright, Principal Program Manager on the SQL Server Engineering team. My team and I cover lots of different areas of SQL Server, including SQL Server on Linux, which we'll talk about today, as well as other things like machine learning services, high availability, performance and scalability, and many more. Feel free to reach out to me at my contact information here on the slide if you have any questions. So let's begin by taking a look at the course outline. In this session, I'll give you an introduction to SQL Server on Linux, and then other people on my team will cover other areas like installation, tools, high availability, security, and so on. And by the time you're done, you'll know everything there is to know about SQL Server on Linux. So to begin with, let's cover the introduction of SQL Server on Linux, and I'll tell you a little bit about kind of the background, the backstory on why we decided to bring SQL Server to Linux, how we did that, and then talk about what is actually available in SQL Server on Linux today. So let's start with SQL Server 2017. SQL Server 2017 is Microsoft's relational database platform. And it really encompasses a lot more than that. It includes things like machine learning services, which allow you to do machine learning and AI in database using Python and R. It's also the most secure database. It has had the fewest number of reported vulnerabilities out of any database platform. And it's also the fastest database platform for several years now, setting #1 TPC benchmarks for both TPC-H and TPC-E. And now we're bringing you the option of deploying on different platforms. And you can also use it with any language. We have drivers available for the most common programming languages like Java, Python, and Ruby, C#, of course, C++. You can use SQL Server with any of these programming languages, and there are many application libraries available for SQL Server. And all of this is done in a way which is consistent with what's available in Azure services in the cloud, like Azure SQL Database or Azure SQL Data Warehouse. The same SQL Server engine powers all of those services as well. Okay, so let's talk a little bit about why SQL Server on Linux. Why now? And really, it kind of comes down to a few reasons, right? So one is that Linux has been growing a lot over the last several years, especially with the growth of the cloud. Linux has become a very commonly used platform for applications, for databases, and so on. And so we want to make sure that SQL Server is an option for those customers which choose to use Linux. Another main reason is because Linux is leading in some areas where you want to have a database platform. So for example, in big data. Also in the area of DevOps and enabling the deployment and lifecycle of data and managing that data in a way that aligns with DevOps principles. And also in the area of containers. We want to make sure that SQL Server is available in a container ecosystem as well. And then we've had a lot of customer demand over the years. And so now we're being responsive to that customer demand and bringing SQL Server to Linux. And lastly, it's really just kind of about creating the market opportunity. And so if we look at the market opportunity of bringing SQL Server to Linux now that it's grown, there's an opportunity for us to go and compete in a space where we haven't competed before. And we all know that competition is just good for everybody. And lastly is that, historically there's been definitely some business challenges here within Microsoft as well as technical challenges that we were able to address. And I'll go over kind of how we resolve those technical issues and really Microsoft's general strategy of being more open and embracing other technologies, including open source especially and Linux, has paved the way for us to be able to bring SQL Server to Linux. So let's think about some of the use cases for having SQL Server on Linux. And the first might be to migrate some of your databases that you have on other database platforms to SQL Server. In the past, if you had, for example, an Oracle database running on Linux and you wanted to move that to SQL Server, you would have to change not only the database engine, but also the underlying operating system over to Windows. Now there's an easier migration path for those folks that want to move from a competitive database running on Linux to SQL Server on Linux. Another example is using DevOps practices with containers. And now with SQL Server on Linux available in containers, you can now automate the provisioning and just general pipeline of pushing out your CI/CD process using SQL Server in containers. Another reason is that customers may be very happy with SQL Server, but for whatever reason, they've chosen Linux as their standard operating system platform. So now for those customers that have historically been running SQL Server on Windows, and those Windows servers have kind of just become an island within their overall Linux ecosystem, they now have the option of moving those SQL Server instances over to running on Linux. and have a complete operating system environment running on Linux for those customers that choose to do that. Another is that developers are more and more frequently choosing to use Mac and Linux as their desktop operating system environment for their development. And for those customers that want to use those types of environments for development purposes, we want to make sure that they have an option where they can run SQL Server locally on their Mac or on their Linux machine. And lastly is taking a look at our partner ecosystem with our SI partners and our ISV partners and helping them expand their business opportunity by taking their applications and services and making them available in the Linux ecosystem as well. And lastly is that there are some hosters out there that specialize in particular in hosting Linux-based workloads. And now with SQL Server on Linux available, those hosters can have the option of providing SQL Server on Linux as a hosted offering to their customers. So with SQL Server on Linux, our goal here is to take that same flexible, reliable data management platform that we've provided in SQL Server for years and years and make that available on more platforms, giving you choice about where you want to run your database. So now you have support for running SQL Server on Red Hat Enterprise Linux, on SUSE Linux Enterprise Server, and on Ubuntu. You also have the choice of running SQL Server in Linux Docker containers, and you can run that on various container platforms like Kubernetes or OpenShift. And you can also run SQL Server on Windows containers for development and test purposes at this point. And we also have made it very easy for you to install SQL Server on Linux by creating package-based installation experiences using package management tools that you would expect in the Linux ecosystem like apt-get or zypper or yum. And with Docker containers, we have container images available up on Docker Hub and Docker Store. So it's easy to acquire those images, pull those down, and run them on your machine. As we went about building SQL Server on Linux, we had some principles that we tried to stick to in terms of how we would make trade-offs and choices as we went along. And one of those principles was that we decided we wanted to have the same performance and scalability for SQL Server on Linux as we have had for SQL Server on Windows. As I mentioned, SQL Server on Windows has long been now a performance leader. We want to bring that same performance and scalability to SQL Server on Linux so that it just becomes a choice about which operating system you want to run on and not a choice of where you get better performance. And we'll go into more detail about the performance and scalability of SQL Server in a later topic. We also wanted to make sure that it was very easy for you to have cross-operating system compatibility. So many of the features that are available in SQL Server on Windows are also available on SQL Server on Linux. So you can easily bring your database from Windows to Linux or from Linux to Windows. We've also done some interesting things around making that a very easy process to move your database back and forth. So for example, you can just simply back up your database on SQL Server on Windows, copy that backup file over to a Linux machine, and restore it over there. And your database will continue to work just like it did before. So there's a high degree of feature compatibility, and there's also a high degree of portability between SQL Server on Windows and SQL Server on Linux. And in general, what we've found is that our application development partners, whether that's a line of business application within your company or it's an ISV application, they're able to typically just move their database over to SQL Server on Linux, change the connection string of their application, and it just works. And lastly is we wanted to create a native user experience. So in general, we want the user experiences to be the same between SQL Server on Windows and Linux. So if you connect to a database, it just works the same as it does whether it's on Windows or on Linux. But in some cases, we wanted to create experiences which were tailored for the platform that SQL Server was running on. So an example of this is rather than creating sort of a setup.exe type experience for installation on Linux, we created the package-based installer experience because that's what people would expect in the Linux ecosystem. And rather than creating maybe registry-based configuration options for SQL Server like we do on Windows, on Linux we use configuration files. So this is just kind of how we try to generally have everything be the same between the two platforms, but for certain things that people would expect to be different, we try to match those expectations on the Linux side. Okay, so let's talk a little bit about the system architecture of how we actually were able to bring SQL Server to Linux. The first option, of course, would be to completely rewrite SQL Server and have it run on Linux. And that's been the approach that some people have taken to bring one application from Windows to Linux or vice versa. But for a product the size of SQL Server, that would really just take way too long to do that. And it would probably introduce a lot of bugs and that kind of thing as you go. So we investigated some different options about how we could do this. And we looked back at kind of what we had available to us. And one of the things that we had available to us was the SQL OS, which is a layer that was introduced in SQL 2005 into SQL Server. And what that layer does in SQL Server is it brings all of the processor, scheduling, memory management, network and disk I/O, and so on into the user mode process of SQL Server, rather than relying on the underlying operating system to do that for us. Because the underlying operating system is designed to be sort of a general purpose, hardware management layer, right? But we have some certain and specific requirements for how a database needs to interact with our hardware. So therefore, we brought that hardware resource management inside of the SQL Server process itself. So at that point, we were really no longer dependent upon the Windows operating system for the hardware resource management and interaction. And then the other thing that we had was a research project here at Microsoft Research called Drawbridge. And the purpose of Drawbridge was really to create a way to isolate a process so that you could have an isolated process running side by side with another isolated process. And especially in something like Azure, where you have a lot of shared tenancy going on, having that isolation is a good thing from a security point of view. But virtual machines and containers also do kind of the same kind of thing. And so that project was kind of shared out publicly as to how we did it or whatever, but then it was never really turned into some kind of a product. But we went and we took that project and we looked at it and we said, this is very interesting. One of the things that they discovered is that they were able to map all of the API calls in the Win32 API layer down to about 50 application binary interface calls out to the underlying hardware. And so we combined together this drawbridge technology and the SQL OS into one thing that we now call the SQL Platform Abstraction Layer. And the SQL Platform Abstraction Layer, if you kind of look closer inside of it, what we do is we take a number of the Win32 binaries directly out of Windows builds, and we package those together with SQL Server binaries into an installable package that runs on Linux. And underneath those 50 application binary interface calls, we map those calls onto the Linux operating system ABIs using what we call a host extension. And that host extension takes all of those calls, intercepts those calls out to the hardware layer, and maps those onto the Linux ABIs. And in this way, the SQL Server binaries that you run on Linux and that you run on Windows are exactly the same. So there's some code paths that go through the Win32 binaries that we ship in this package, and there's some code paths which were performance critical that go through some specific code paths that we built for the Linux operating system in that host extension. And the result is really awesome because you don't have to rewrite SQL Server. And every time we ship a new bug fix or we ship a new feature in SQL Server, it shows up on Windows and on Linux at the same time because it is the same binaries. And an example of that is the new SQL Graph features in SQL Server 2017. So we added the ability to store graph data in SQL Server. Well, that feature showed up on Linux and on Windows at exactly the same time. In fact, that feature was developed by developers here at Microsoft using SQL Server on Windows, but then it just worked on SQL Server on Linux. Now, usually one of the first things people ask about when they see this architecture is, you added this extra layer into your architecture. What is the impact on performance of that? And so we worked with our partners, Red Hat and HPE, to publish a new TPCH #1 world record benchmark back in May. And this was done on Red Hat Enterprise Linux and on HPE hardware. And we were able to set a new world record with this architecture. So the answer is there's very little, if any, impact of having SQL Server running on this platform abstraction layer. And it gives us the isolation and it gives us that abstraction and without any sort of performance hit. And then we followed that up with our partners SUSE, and we built another TPCH benchmark world record. And this time we used HPE's persistent memory to publish that new world record as well. And later on, Jamie, in the performance section, will go into more detail on exactly how to tune performance and how we went about getting these performance benchmarks. So what's in SQL Server on Linux? What is included, what's not included? So first of all, think of SQL Server on Linux as being primarily about the database engine. And within the database engine, all of the features that you would expect to be there are pretty much there. There's a few exceptions. In addition to the engine, we also have made integration services available on Linux. Some of the other services like reporting services, analysis services are not yet available on SQL Server on Linux. So within the engine, though, let's kind of take a look at that, right? So we have things like in-memory technology, we have column store, we have all the security features like transparent data encryption, always encrypted, and so on. We have the services around the agent, for example. We have features around all of the developer interfaces, all the libraries work with SQL Server on Linux, and so on. And so just in general, all of those things are there. So the notable exceptions to what's not available on SQL Server on Linux right now are machine learning services, reporting services, analysis services, master data services, data quality services. But with that engine, almost the entire engine is there. So let's take a closer look at some of the features that are available in SQL Server 2017 at general availability. As I mentioned, we have support for Red Hat Enterprise Linux, Ubuntu, SLES, and Docker. We have package-based installs. We have support for running SQL Server on OpenShift and Kubernetes. We have support for running failover clusters with high availability, and we also have support for always-on availability groups, which uses our replication-based HA. We have support for backup and restore. We have support for doing log shipping through the agent. We have support for transparent data encryption, always encrypted, row-level security, dynamic data masking, all of those security features. And we have support for management tools like an operations manager management pack for System Center. And we also have the DMVs working for SQL Server on Linux. So those dynamic management views can give you insights into how your SQL Server is performing and how it's configured. And we also have support for full-text search. For developers, all the programming features that you would want to use, like in-memory and column store, partitioning, compression, all of those kinds of things are also available in the engine on SQL Server on Linux. We have support for JSON, XML, Graph, and we've also done some extensive testing with all the various tools. So things like SQL Server Management Studio running on Windows will work with SQL Server on Linux. Our command line tools like SQL CMD, BCP, our new tool MS SQL CLI, all of these things work with SQL Server on Linux, whether you run them on Windows or on Linux or on Mac. And all of those tools are designed to just work in the same way, whether you're running them on Windows, Linux, or Mac, and whether you're connected to SQL Server on Windows or Linux. And we also have a couple new GUI options for tools. The first one is a Visual Studio Code extension that's available. And because Visual Studio Code runs on Windows, Linux, or Mac, you can run it on any of those platforms and then connect to either SQL Server on Windows or Linux. And we also have a new tool called SQL Operations Studio that is in beta right now. And you can go and grab that, and that also is a cross-platform tool that's designed around a bit more of like the administrative scenarios that you might want to do with SQL Server on Windows or on Linux. So that kind of wraps up the introduction. Next up, we'll be installing SQL Server on Linux, using Docker containers, and kind of some scenarios around using SQL Server in DevOps. And that's a good way for you to just get started with installing SQL Server on your own laptop or on your own server in your lab and start to play around with it and get your hands on with actually trying out the product as you're learning through this course. So thank you very much for joining us today, and we'll talk to you soon.
Hi. I'm Eric Kang, a Senior Program Manager in Azure Data. In this module, we will learn about installing and running SQL Server on Linux in Docker containers and how we can apply this new concept in database DevOps practice. First, we will quickly go through an overview of database DevOps and Docker container. Then we will walk through the basics of running SQL Server in Docker container, deploying the container to Kubernetes cluster in Azure Container Service, and automate the end-to-end flow with the multiple demos. So, what is DevOps? DevOps is about people, product, and process that can easily collaborate together to innovate faster and continuously deliver the values. More specifically, or in a very practical focus, it is application, database, and the application and the database CI/CD which is a key ingredient in Agile DevOps practice. So this is very familiar flow. In application and also database CI/CD, it works like this. First, all those code for application and database is in code repository, like a GitHub, VSTS, and source control. Whenever there is a change in the code, it starts building and testing those changes. Once it is done, it deploys to target environment. It can be a test environment or production environment. Once it is deployed, we monitor, get feedback, and find the bugs. That goes back to the developers. The developer changes, fix, and enhance the application and database, and check in the code back into code repository. And then it repeats again. So when we look at the DevOps and CI/CD perspective, also with the data perspective, what it happens? We have a production environment and development environment. In between, we have a pre-production environment typically. So in production and pre-production, we have a production data. And when it comes to development environment, we usually deal with the sanitized data instead of dealing directly with the production data. So whenever a new sprint starts, let's say it's 3 weeks or a month, then in the pre-production, we create dev and test environments. That is consumed by developers in dev and test environment, and push the change. And then whenever there is a change in the code, there is a check-in test, which is a unit testing or any test that is necessary. So this part is called the CI. And it repeats during the sprint, and it can happen multiple times a day even. And when those CI integration is continuously done and we are reaching up to a sprint finishing, then we run the scheduled test. Once it is passed, then it goes into the deployment cycle. So in that case, we create a pre-production environment, and then we run the pre-production test, and then it pushed into a production side. So this is kind of a flow that we deal with in the DevOps CI/CD practice in data. All right, so let's jump into a Docker story, keeping that in mind. How Docker can help us enabling this CI/CD pipeline with a database application as a whole unit of development, test, and deployment. The first, the Docker container is providing us a benefit that is very fast to deploy. And it is portable. That means when we build and package up our changes in the Docker container, then it can be portable, that runs on the dev and test environment, and then it can run on the pre-production and the production, all same way, without change when it travels through the different environments. And it's very predictable. That means if code is changed in the dev and tested, then it is guaranteed that the same code and then the change works in other environment as well, which is a very good benefit when we are dealing with CI/CD in complex environments. Also, when application and database is packaged up in the container, then we can easily build a high-scale and high-density container cluster platform using our container platform like a Kubernetes and Azure Container Service, AKS. So from dev perspective, it is very productive to work on the development and test cycles in the Docker container environment because of the portability and the predictability. And there's no more saying not reproducible bug case anymore. For operations perspective, it is very easy to have a control over the environment because the Docker container is based on an image which is immutable. From an ops perspective, they can configure and build Docker images for dev, test, production in an identical way. And that considers like application, SQL Server instance, runtime, dependence, components, all together. So wherever it goes through the portability, those defined set of application components travel together. And this synchronization can be fully automated. we are going to take a look at the CI/CD and DevOps perspective using container in this module. All right, so let's start with some basics first. So what is the key ingredient and the key commands that we need to know and understand to install and run SQL Server on Linux in Docker container? So this is a very basic starting point. You can start with the 3 commands. One is docker pull and docker run. Once it is I will actually go through the demo, like a hands-on lab style, so that you can follow me and then try it by yourself. And the 3rd command is called the docker compose. You can install this docker compose tool on top of Docker in your the dev environment and the test and production environment, that you can package up multiple containers like a database application or unit testing containers all together as a single unit of application. Okay, let's take a look at the demo, and you can just follow and pause as you wish. What I have done is that I installed Docker on my laptop, and I have installed a SQL Operations Studio, and I have a Git cloned demo project, which is publicly available. In the reference slide, you can refer to how to clone this repository, and you can also follow the same step together. Okay, let's take a look at the basics.sh, which has multiple commands. The first one is pulling the Microsoft SQL Server Linux latest image from Docker Hub. So how Docker works is that it requires a Docker image which contains the baseline application. In this case, this is an MS SQL Server Linux latest version from the SQL Server 2017. All right, so simply you can open up the command prompt. I'm pressing Ctrl-tilde and then run docker pull commands. Docker pull pulls image from repository, which is hub.docker.com in this case, and Microsoft account, and the image name, which is MSSQL-Server-Linux and latest version. For your project, you can use private repository, such as a private Docker Hub repository or Azure Container Registry that you can create in the Azure service. And you can pull your image from your private repository. So after you run this one, if I run Docker images, you can see all the images that was pulled from one of the Docker registry or Docker hub. Okay, once you have the Docker image, now you can spin up a container using that Docker image. So in this case, I'm going to call docker run and name the container as a demo SQL Server. For SQL Server, there are important parameters that you have to provide. One is a port number. The default it is 1433. I can change the port number to a port number that I wish. In this case, I'm defining the port number to 1431. And the next 3 is environment variables that you accept EULA and define the as a password and the addition of SQL Server using MSSQL-_PID. Please note that for the demo purpose, I'm using as a password environment within the command, but you should make it secure by defining it in the environment variables or something like that, instead of putting it in your source code and check it in to a repository so that the other people cannot see your password information for SA. Okay, so the last parameter is defining that I'm running the container in detached mode. That means that it runs like a service. And I'm defining the image name that we just pulled down. So let's run this one. All right, so within a couple seconds after downloading the image, if I run Docker PS, SQL Server is up and running. It's really fast, so developers or test environment can deploy SQL Server in a couple seconds after the image is downloaded. If you want to remove the server container, then you can run docker rm-f and the name of the container. So let's do that. Okay, if I run the Docker PS, then there is no server running. That is the basic commands that you can pull and run. Now, when you think about the development environment, what developers deal with is that they need to have a SQL Server running, and they need to have an application, and they need to have some test container that runs a unit testing or integration testing all together. Those all three, let's say, containers are a unit of application. So how we can easily compose those and run three containers or multiple containers as a single unit of deployment and the provisioning. So a tool that is called the Docker Compose actually helps you to do it really quickly. The requirement is that just to define those containers in docker compose.yml file. So let's take a look at quickly. So if you take a look at, this is a well-defined JSON definition represented in the YML format. What you need to do is define the containers called as services, and the one is MS SQL and application. So in this case, I'm starting SQL Server and the web application as a single unit of deployment. So if I take a look at it, I have created a custom image of MS SQL Server that contains my database backup files in it and the necessary script that I often call. So I made up my own version of image and then uploaded it into a private repository that I have. And I have a container name, which I call it MS SQL. And same as the Docker run, I define the port number and then set the environment variables. For application side, it's the same thing. It's the same pattern. You define the image name and define the name of the container, and then define the port number, which is a web application. So I'm going to use port 80. So when we have this docker-compose.yml configured, from developer perspective, what developer needs to do is just to run docker compose up-d command. By running this one, also within a few seconds, all my SQL Server application entire environment that I need to run my dev actions are up and running, and then I can easily start my development and then the bug fixing, testing, all that action from there. All right, in previous hands-on lab demo, we went through a Docker pull, Docker run, and Docker compose. During that lab session, we actually saw I have created a custom image, and then I started using it as part of my application and database. So it is kind of common practice when you are practicing the database development and application development in the Docker environment that you create your own image for your project and then build it and then push it into a public or private Docker image repository so that you can share that with your team, or that the same image is used to deploy onto a target test environment or pre-production environment or even production environment. So let's take a look at what we can do. So again, in this session, you just consider three things. One is Docker file, and the two commands, Docker build and Docker push command. Let's take a look at. Again, you can follow each step like a hands-on, so you can pause and start as you wish. I opened up the second file, which is a build your own.sh file. So it contains two commands. Basically, building a Docker and pushing the Docker image is a very, very simple operation. It calls first docker build, and here dot means defining the same location, which means the same folder, and I'm tagging it to my image name and the name of the repository. Okay, so to build a Docker image, what you need is defining a Docker file. So I opened up the Docker file. It is very simple definition. It has a pattern that always it starts from close, from command, which defines what is the baseline image of your own Docker image. So in this case, it can be Microsoft MS SQL-Tools latest version as my baseline image. Or it can be, if you're actually extending your MS SQL Server -Linux image by adding some backup files in it and the necessary components in it, you can start from that image, MS SQL Server -Linux and latest. So what I'm showing you is the pattern, how you can compose your own Docker file. And after you define your baseline image, then you can add multiple commands as you wish. First, work dir is defining what is a working dir directory when container starts. So it's more like a starting directory or folder when container starts. And there, I am copying restore.sql file, which is the sample example. You can copy entire folder or anything that you wish into the image, or you can even run any command. Like if you want to install more packages, like using apt-get, you can run apt-get and name your package names there. So it can get installed along with the SQL Server and runs in the same container. The last command is the cmd that defines when container starts, what is the command that you want to run as a part of the bootstrapping of the container. So that is basically the simple definition of a Docker file. And let's try this one using our demo. So using that Docker file in the same folder, which is under AKS folder, I can simply run the command. Okay, so it basically takes the Docker file and using it as a spec or instruction, it builds a new image that is called Eric Escong /demo image and latest. And once you log in to your Docker repository or ACR using Docker login, then you can push the image into the repository. So if I run Docker push, then as you see, the newly created image is published into your Docker registry. Once Docker image is published into a Docker registry, then anybody who has access to the registry can pull down the same image. The MS SQL Server Linux image is built in the same way, and we have pushed into the Docker Hub so that you can run Docker pull and pull down the image. It's the same pattern, same way of working. In the previous modules, we have walked through the basics of using Docker and Docker container for SQL Server and any other application deployment. So we learned Docker pull, Docker run, Docker compose, Docker build, and push for your own Docker image. In this module, we are going to learn about container platform. And let's start. So when you have a Docker images and the Docker container, ready, then you can actually deploy that container into a container platform. So the container platform, a well-known one, is a Kubernetes. The key benefit of running containers in the container platform is that you can easily build a container cluster at scale with a very high density manner so that you can maximize the utilization of available resource that you have. And another key benefit is that the container platform manages the health and resiliency of the container. So if a container fails, then it checks the health and restarts the container automatically if you define it that way. You can run Kubernetes or OpenShift or Mesosphere container platform anywhere, but Azure has a service called Azure Container Service, which is very easy for you to provision and deploy and manage persistent storage for SQL Server usage. The key thing about the persistent storage is about the SQL Server needs to store its database files in that persistent storage. So remember that Docker container is ephemeral. So if Docker container is stopped and it's removed from a Docker engine, then all those data which was stored in the container itself is deleted along with it. So it is always important to store database files outside of a container, which is called persistent storage. So if you use Azure Container Service, then Azure Container Service has a built-in storage support, which is using Azure Disk. We are going to go through it together. And please remember, persistent storage is a key concept when using Docker container for SQL Server on Linux. So here, when we are dealing with the Kubernetes in AKS, Kubernetes has a command line tool which is called the kube control. And kube control defines a way that you can interact with the Kubernetes API very easily in the command line. And then you can also automate it using the command line tool. So here, the one key command that you want to and need to remember is kube control apply. Let's go through the hands-on lab demo and see how it works together. The first, I'm going to show you provisioning of Azure Container Service. Okay, so the requirement is that first install Azure CLI, the latest version, and the login using as login command. And if you have a more than one Azure account subscription, then set which subscription you are going to use to deploy AKS. In the subscription, there are three pre-requirements. One is a container service. The second one is Microsoft.compute. And the third one is Microsoft.network. So for these providers, you can call as provider, register command, and just to call these three. This is a one-time setup that you need to do. Once it is done, then just run as group command to create a new group that will store or Kubernetes and AKS related resources in the same group so that it's easier to manage. To do that, just to call as group create command with a name. We are going to name it as a MVA demo KS group and define the location. The location can vary based on your subscription and your preference. I'm going to use West US 2 as the region of Azure service. Okay, so once that is done, it's all prereq. Then the actual command is a one line to create Azure Kubernetes, Azure Container Service with a Kubernetes. So the command is that as AKS create and define the group name that we just created and name the cluster We are going to name it as MVA demo K8S cluster. The next two commands are important. One is a node count. So because we are going to create a cluster of nodes that can host the multiple containers and load balance, so node count is important one. You can start with the 1, and you can increase using scale command later on if you need more. So I have a sample below for the scale command in that case. And the next one is that defining the VM size for each node. So if you define a node count 1, then AKS will provision one virtual machine in Azure using the pricing tier that you can define. In this case, I'm defining standard underscore D2S underscore V3 for demo purpose. You can scale up and down if you wish. So that is basically the key parameters that you need to provide for AKS create command in Azure CLI. So you can run this one. I already ran this one for the demo prep. It will take about 10 minutes or 15 minutes, and it's a pretty simple step that you can have entire Kubernetes cluster in AKS in that short amount of time. So once it is created, if you go to portal and the resource group that you have created, then you can see AKS provisions one virtual machine of the pricing tier that we defined and necessary network definitions. And it also provides the load balancer, which is very handy. I'm going to cover this one in the later section. And it defines the disk that is used by the node itself. Okay. Once that is created, to be able to access the cluster from your local machine or laptop, for example, using kube control, you need to have the cluster context in your local machine. So to do that, simply run this command as AKS get credential and provide the group name and the name of the cluster that we just created. Once you do that, then I will actually run the kube control command. Kube control can access all of these clusters, Kubernetes clusters, and the set MBA demo K8S cluster as my default connection. So from now on, when I run kube control command, then it uses the credential that we just set as active one and the current one and use it to make a connection. So let's run kube control cluster info. Then as you see, it is all up and running, and now I can interact with the Kubernetes cluster from my own laptop. So this is a one-time prereq to set up a Kubernetes cluster in AKS, which is pretty simple that you can do in 10 to 15 minutes. Okay. Once you finish that one, then it is a real operation that you can deploy your SQL Server on Kubernetes cluster in AKS. So let's go through it one by one. Okay. So I opened up the deploy to AKS demo file, which is number 4. So what we are going to do is that first we are going to deploy a namespace. Namespace is just the regular namespace that you can group related containers within the same boundaries so that you can easily manage it. So you can just name it whichever you want. In this case, what you need to do is that you need to define those specs in a file called namespace.yml. Any file that you can define in the Kubernetes format. So in this case, I define the kind of resource that I'm deploying to Kubernetes is namespace, and give a name production, which is my selection of the namespace name. And I also have another namespace, which is a SQL DevOps that I want to provision altogether. So that is the first file that I'm going to run as a preparation of my environment. So if I run this one, okay, so namespace, production, and SQL DevOps are both configured, and it's provisioned. To get the information from Kubernetes in AKS, you can use a kubectl get namespaces. Then you can see production and SQL DevOps are provisioned in there. Okay. So now, to deploy the SQL Server on Linux running in the Docker container to Kubernetes, first thing we need to care about is dealing with the persistent storage. So we have a pvc.yml file that I defined a persistent storage. Let's take a look at it briefly. The concept is that Kubernetes has a persistent volume and a persistent volume claim. So persistent volume is a pool of resource that you can use with the definition of persistent volume claim. So for example, in this case, I'm going to claim 10 gigabytes of space, and I will name it as a SQL PVC claim 1. And I put it in the production namespace. When I'm claiming it, the storage that I'm going to use is defined under storage class name, which is default. I'm going to explain what it means in a few seconds. And the access mode is read-write-once. So this is pretty much like the simplest volume claim for SQL Server running in AKS Kubernetes cluster. So let's first look at it. So to create a claim in the Kubernetes cluster, you simply run kubectl apply -f pvc.yml. That's what you need to do. I actually ran it before this session. So let's take a look at what has been provisioned. So as you see, SQL PVC claim is created, and it's bound with the PVC volume, which is automatically provisioned by AKS using Azure Disk, and the capacity of 10, read-write only, and storage class is default. Okay, and let's take a look at what the storage class means. If I run kubectl get storage class as C command, then you can see the available storage class, which defines the storage, which defines the driver for persistent volume, which is the definition of a storage class, which is in this case the default is Azure Disk, and another one is a managed premium class, which is also using the Azure Disk, but in this case it uses the premium Azure Disk, which has a larger size and a faster I/O, so you can choose based on your need. So by defining the storage class for your persistent claim, you can automatically provision a claim for that one. In Kubernetes, there are more storage classes, like the NFS is one case, and then you can deal with third-party storage classes that you like. And to do that, what you need to do is the deploy the storage class provisioner container into your Kubernetes environment and start using it by defining your storage class within the persistent volume claim definition, which sounds a little bit complex, but once you have the persistent volume driver installed on your cluster environment, then it's very straightforward after that. Okay, so once you have those purchase and volume is defined, then now you can deploy SQL Server using that as your storage for data files. To do that, I defined SQL-statefulset.yml. Let's take a look at what it does. For SQL Server, I defined the pod type as a stateful set, and I named it as MS SQL, likewise other Docker container demo that we have went through today, and defined the namespace into production. So what is important in this case is that for SQL Server, I'm going to use the SQL PVC claim one that we just created as my volume for SQL Server, and I named it as a SQL volume. And I'm creating a container from the latest MS SQL Server Linux, name the container as MS SQL, open up the port 1433, and the same thing as we saw in the Docker run, defining all the environment variables there. And here, volume mounts is the location that we define on which folder in the container we want to use the purchase and the volume that we just linked up together. So in this case, SQL Server on Linux, data files and all those log files are located in -bar-opt-MS-SQL. So entire folder we are going to mount to the SQL volume purchased in the storage. That means all the master MDF file, temp database, MSDB, and your user databases all along will use this folder, and it is stored in the purchased into storage, which is outside of your container. So even though this container within the Kubernetes faces a health issue, and it is recreated in different nodes in the Kubernetes cluster, the data stays without losing all the contents, which is very important in that perspective. Once you define that it is a simple, just running kubectl apply -f and then the Kubernetes spec file in YML format. So let's run one by one together. Okay, first the command, I'm deploying the SQL Server database container into Kubernetes. In the second YML file, I deploy my web application. That's about it. And let's take a look at what happened. If I run kubectl get services command, it shows all those services that we have defined in the YML file and provisioned. In this case, as you see, MS SQL, which is the SQL Server database container, is running, and also web application is running. Because we are simulating this environment as production, what we've done is that we are not exposing SQL Server to public internet. So in this case, it is defined as a cluster IP. That means the MS SQL container is only available within the Kubernetes cluster environment. And any connection from outside of cluster will not be allowed to connect MS SQL. On the other hand, web application is defined to use load balancer type. That means that it automatically gets external IP. When we saw the resources for Kubernetes in Azure portal, we saw that the Azure AKS automatically creates a load balancer as a part of Azure service, which is a good thing. That one of the benefit that you get when you're using Azure service instead of you're building your own Kubernetes cluster in your own private environment, where the load balancer will not be available unless you set it up by yourself. So in this case, web application is running within cluster with this IP, but also it is exposed to public so that the users can directly connect to that IP and use the web application service as we wish. So that's basically what it happens. And the web application internally within the cluster access MS SQL and then operate the data operations using that communication. Okay, so let's try that one. Because we have deployed it, now if you go to the IP, then as you see, our application is now up and running within the Kubernetes cluster. So far, we have walked through the basics of Docker and then how you can utilize Docker container in the Kubernetes cluster in Azure Container Service. In this module, we are going to run through then how we can automate this end-to-end practice using Visual Studio Team Service. All right, so let's put together all these scenarios into automated CI/CD workflow together. So as we see, first, all our source code, including the definition of Docker files and the Kubernetes specs in YML, let's assume that it's all in source control, along with your database change code and the application change code within it. So whenever there is a change in source control, Visual Studio Team Service monitors the changes in source control. Once it is detected, you can automatically trigger a continuous integration build and ask VSTS agent to start the job. The job that VSTS agent execute is Docker build and Docker push that we already saw in our demo. The importance is that all those command line actions and scripts that we have walked through today is all automatable using Visual Studio Team Service and the Visual Studio Team Service agents. Now, when the new image with the source code change is built using Docker build and then pushed into Docker push, then it goes to a Docker image repository. In this case, we create new MS SQL image with my custom components in it, and web application changes, and the test runner all together. Once build is successfully complete, including push the image into Docker image repository, VSTS can detect it and start an automated deploy process. And when we do that, we can define it in the multiple workflow steps. So first, we deploy that changes to dev and test cluster. As we saw before, we can use kubectl apply using the same spec, and then the images will be deployed to dev and cluster as a Docker container running in Kubernetes and AKS. And we can define with a test runner running necessary unit testing or integration test within the test and dev and test cluster. Once it is successfully done, VSTS executes the next step automatically or through the approval process and running the same kubectl apply command. In this case, it can deploy MS SQL database image or web application into a pre-production or production cluster. So this operation occurs whenever there is a source control change, or you can schedule it like running once per day or multiple times a day at a specific time. Let's quickly take a look at how it can be done very easily in VSTS. I opened up my Visual Studio Team Service project, which is called the SQL DevOps-container. To automate the process, first, you need to define a build definition for CI build. And for release, you can define a release definition in Visual Studio, which is very simple. I'm going to show you one of the build that was successfully completed in previous run. So here, if I look at the build definition, what it does is, first, it gets source from a source control. In this case, it was a GitHub, and starts a job, 3 jobs, on an agent, which is a Linux agent in the Visual Studio team service, which is a hosted agent that is automatically provisioned and then assigned to my project. The first step and the last step is basically calling Docker login so that my agent knows which account to use to build and publish my image. And cleanup is just get rid of the Docker images that was produced as a part of the build definition. So it's just to clean up the interim artifacts. So main thing is basically calling docker build and push.sh. It is same as the docker build and docker push command that we walked through in previous module. That's basically what you need. If you define all those docker, the build and push command in the command shell, then you can use it like a bash command and execute it. VSTS also provides a template for the same operation. So if it's your preference that you can use the VSTS template instead of using the command shell and run the bash command for yourself or PowerShell command for yourself. So if you type in a Docker, then you can use a Docker template to run Docker commands. And if you wish to run a Docker Compose, then the VSTS also provides a Docker Compose, the command as well that you can use for your CI/CD automation. For Kubernetes operation, VSTS also provides a deploy to Kubernetes template. So basically, it's calling kube control commands, but it provides your UI interface that you can use to define what and how you are going to deploy your containers into Kubernetes environment. So which is very handy that you can use it on UI. Basically, the content of the configuration for deploy to Kubernetes are exactly the same that we have walked through using the kube control apply commands in the previous module. All right, in this module, we have gone through multiple parts of installing, running SQL Server on Linux in Docker container, building your own image for SQL Server on Linux, and also deploying it into Kubernetes, as well as automating it using VSTS. There are a lot of contents in this module. All of those scripts and the steps are uploaded into my GitHub project. So you can get that demo script and you can replay the same the flow by yourself. To do that, you will need to learn a little bit about Docker itself and go to docker.com website. Also download both the Docker and the Docker Compose tool together. For Kubernetes, you can go to kubernetes.io website and learn about more for the container platform concepts and the details. The recommendation is that start with the AKS, which has a very easy way to provision Kubernetes cluster on Azure VM services And it's very, very simple as just calling one command as we walk through together in this module.
Hi, I'm Mihaela Blenda, a program manager on the SQL Server team. In this module, I will give you an overview of the mission-critical HA and DR capabilities that are available with SQL Server 2017 on Linux. To provide some background, I'm a senior program manager on the SQL Server engineering team. In that position, I focus on SQL running in Azure VMs, as well as high availability and disaster recovery scenarios for SQL Server. Since early preview days for SQL Server on Linux, we stated that our goal for new platform, as well as Windows, is to enable organizations to achieve a broad range of availability SLA goals. This is to accommodate various business requirements. And we used this framing to talk about various options customers have for implementing HADR with SQL Server. With simple HA solutions, organizations leverage virtualization technologies to achieve a high degree of resiliency against host-level failures, fault tolerance against hardware failures, as well as elasticity and resource maximization. These systems can run not only on premises, but simple HA applies to SQL Server running on private or public cloud or hybrid environments. For simple DR, the fundamental form of disaster recovery and protection is the database backup. Then we have standard HA solutions with instance-level protection combined with reliable shared storage infrastructure, or database-level protection with always-on basic availability group support. And for DR, once baseline data protection is in place with backups, the rest of the environment can be customized to the needs of the organization for additional disaster recovery. One such option for standard DR is log shipping. For mission-critical SQL workloads, always-on availability groups is an integrated solution that provides redundancy within or across data centers to help enable fast application failover during planned or unplanned downtime. Now, with SQL Server 2017, customer can leverage all these capabilities both on Windows and Linux. The biggest addition to SQL Server 2017 is the support for SQL Server on Linux distributions. But there are other aspects that we invested on. For example, enhanced Microsoft Distributor Transaction Coordinator support for Windows Server-based configurations, configurable number of required sync write commits for availability groups to enable enhanced data protection in addition to high availability, or cross-platform scenarios with backup restore, log shipping, and availability groups. And ultimately, additional read scale-out scenarios with Windows and Linux. We're going to focus now on some of the high availability features enabled on the new platform for SQL Server 2017. So to start with, for organizations that are building mission-critical applications running on a Linux infrastructure, we have always-on availability group support. This feature is now available on all Linux distributions SQL Server 2017 supports: Red Hat Enterprise Linux, Ubuntu, and SUSE's Linux Enterprise Server. Also, all capabilities that make availability groups a flexible, integrated, and efficient HADR solution are available on Linux as well. To name a few, multi-database failover, transparent failover using floating IP resource, multiple sync and async secondary replicas, manual automatic failover with no data loss and read-only secondary replicas. Automatic seeding and database-level health monitoring and failover trigger, as well as disaster recovery configurations are also available. Now, let's have a look at how HADR solutions are implemented in Linux. We know that in order to achieve a higher availability SLA, we need a cluster to coordinate the automatic failure detection as well as the automatic failover trigger in case of failures that cause application unavailability. On Windows, always-on depends on Windows Server failover cluster for distributed metadata storage, for the failure detection aspect and failover orchestration. On Linux, we are enabling availability groups to integrate natively with Linux clustering technologies like Pacemaker. You can add a previously configured availability group as a resource to a Pacemaker cluster, and all the orchestration regarding monitoring, failure detection, and failover is taken care of. You're going to see it later in the demo how to configure this high availability setup. But one important design consideration I'd like to mention before is that while in Windows, SQL Server is tightly integrated with Windows Server failover cluster, and workflows like failover, for example, are built on a communication layer that goes both ways. For Linux, we chose a different approach. Both for shared disk failover cluster and availability group solutions, SQL Server is not what we call cluster aware and is managed by the cluster orchestrator in an outside-in manner. The APIs used to integrate are public, using the regular T-SQL failover APIs that we all know, and such that customers can also integrate with other cluster technologies. This led to introduction of a cluster types concept. We have the existing Windows Server failover cluster, as well as external, which is the new option that we are going to see shortly in the demo, or none, which enables some very interesting scenarios as well that we're going to talk about later. Based on our customer engagements, one common scenario with Windows Server failover cluster is two sync replicas with file share witness. On Linux, when cluster type is external, configuration metadata used in failover arbitration is stored within SQL Server. So customers must configure a third sync replica to get the automatic failover with data protection guarantees. The cost aspect related to having a third replica is not negligible. So starting with SQL Server 2017 CU1, we enabled customers to use a SQL Server instance, including Express, to host a configuration-only replica. So a configuration-only replica will not receive any user transactions traffic. It will only receive updates and store the availability group configuration in a synchronous mode. So the solution solves the cost aspect, as SQL Express is free and has minimum hardware requirements. Let's see all this in action. I'll go through setting up an availability group and add it to a Linux Pacemaker cluster and simulate a failure to see an automatic failover. Okay. So I already have the cluster set up. This is a Pacemaker cluster, and let's see its status, for example. So as you can see, I have 3 online nodes, but at this time, I don't have any resources configured. So we're going to go ahead and go to SSMS to configure the availability group. I was mentioning earlier that one of the configuration options we introduced with SQL Server 2017 CU1 is the capability to have a configuration-only replica on an Express instance to hold the availability group metadata. And this is the case that what I have here. So one of the instances that I'm going to create availability group on is an Express instance, as you can see here. So now we're just going to go to the availability group wizard. This is well known, no different experience from the Windows workflow. I'm going to choose cluster type external because, again, Pacemaker is an external cluster entity that it will manage my availability group, and choose all the replicas that I want them to be part of my availability group. And this is the third replica, which is, again, an Express instance that will hold my configuration-only replica. This replica won't have any data, will not hold any data. Okay, so I'll make them synchronous commit, the sync replicas, and then I have the configuration only as well. I'm going to choose automatic seeding. This is a new option that we added in SSMS recently. And let's wait for the workflow to finish. The secondaries will sync to catch up with the primary, and then we're going to have the availability group created. So now the secondaries are joining to the AG. And everything is successful. We're going to go ahead and look at the dashboard to see if everything is healthy. We should have everything caught up. Yep. So we have the primary and the 2 secondaries, with one being a configuration only. So this cannot be a target of a failover or anything, right? It will just participate as a witness, if you want, in the failover orchestration. Now, going back to the cluster, I'm going to show you how to add the availability group that we just created as a resource in the pacemaker cluster in order for the cluster to orchestrate the monitoring and the automatic failover aspect. So using the cluster management tools like PCS, I'm just going to add the availability group as a resource in the cluster using PCS resource command, and just have to pass the availability group name. And then, in order to have this transparent reconnection aspect, I'm going to add also a virtual IP resource to the cluster. So that will ensure that once the failover happens, the floating IP or the virtual IP will follow the primary on that node, on the failover target node. So using the same command line tools, PCS, I create another resource, which I will call virtual IP, and provide an IP within the network, right? And then I'm going to add some constraints such that the virtual IP, as I was telling you, will start after the master resource will start on the target of the failover node, right? And the second constraint is that, as I was mentioning earlier, we want the virtual IP to always follow the master resource type, right? When a failover happens, we want it to be co-located with the master resource. So that's exactly what we did now. And then I'm going to create this order constraint to make sure that the master is started first and then the virtual IP. So I don't have unnecessary failures, right? So once we finish creating all this, then we're going to see the status of the resources again using the same PCS status command that we used earlier to see the cluster status. And we see now that we have the primary pretty much on MBU 1 and also the virtual IP is on the same node. So now I can use the floating IP to actually connect to the primary. So when a failover happens, I don't have to change my connection string, right? So just doing the same thing, looking at the dashboard, we see the same thing because the primary is on the same node, but we're going to show shortly how to simulate a failure, and we're going to see that we don't have to change the connection string using the floating IPs in the connection string is enough, as it will point to the target of the failover node. All right, so now to simulate the failover, I'm just going to stop the SQL Server service on the primary node. Now, so the service is now stopped. And using crmmon command, we can monitor what is happening in the cluster and regarding the resource status. And we already see that the cluster detected that the service is not up on the primary node, right? And it will try to demote it to make it a secondary, but because it's not available, it will try to promote one of the secondary replicas. Right? So we saw on the dashboard that there is a failure detected, right? And the failover happened. Right? And if we try to restart the SQL Server on the failed node, we will see that it will rejoin the cluster as a secondary, right? So now we have the primary in one of the former secondaries, and the former primary joined the availability group as a secondary. And the SSMS dashboard is showing us exactly the same thing. Now, moving further on the scenarios that we enabled with SQL Server 2017, let's talk about migration across the two platforms, Windows and Linux. Using SQL Server 2017, you can now migrate SQL Server workloads cross-platform by setting up a distributed availability group with primary availability group on Windows and the secondary on Linux, for example. This would be the fastest solution to migrate your high availability infrastructure cross-platform with minimum downtime. And distributed AGs are also another method to migrate to a new configuration or upgrade SQL Server. Because a distributed AG supports different underlying availability groups on a different architecture, for example, you could change from SQL Server 2016 running on Windows Server 2012 R2 to SQL Server 2017 running on Windows Server 2016. In terms of hybrid platform, there are several configuration options that you can leverage. You can configure a hybrid operating system configuration for migration, testing, or even DR scenarios. Or you can have a hybrid platform configuration using that crosses the premise infrastructure, the on-premise infrastructure to the cloud, for example, for a cost-effective DR solution. Changing the platform focus a little bit, we hear a lot of questions around what about HA and container support. While automatic failover for availability groups is not yet available, as there is no cluster solution to support this scenario, you can still leverage orchestrator features like Kubernetes deployments, replica sets, services, and persistent storage to enable a high availability configuration. For example, you can deploy SQL Server on Kubernetes cluster running on Azure Container Service and use replica sets to achieve a high availability configuration, very similar to a shared disk failover cluster instance configuration. In this case, Kubernetes plays the role of the cluster orchestrator. Upon a failure of SQL Server instance running in a container or a node failure, the orchestrator will bootstrap another instance of the container that will attach to the same persistent storage that maps to the Azure disk. Let's see how this looks like. I'm going to show you how the Kubernetes cluster in Azure Container Service looks like, and then simulate a failure and see how the orchestrator will recover from that. So I have already the cluster configured, and this is the dashboard that we have available to see the Kubernetes cluster in Azure Container Service. I already configured the storage type with Azure Disk, and we see that we have a deployment and then the replica set to the replica count of 1, right? So in this case, Kubernetes will ensure at all times that I have one instance of SQL Server, a container containing one instance of SQL Server running. I also use a service type deployment to have an external endpoint that I can connect to. So in this case, I can use this, it plays the role of load balancer as well, right? So in this case, I can connect to this IP from outside of the cluster, right? And then I have access. For example, I can just, in this case, I'll just create a database, for example. Right, and then going back to the dashboard, I can simulate a failure by going to the pod that is running SQL Server. So we know that now it's running, for example, on the node with IP ending in 05. I can simulate a failure by deleting it. The orchestrator already detected that they have to recover the instance. Right? We already see that we have another healthy pod. And in this case, for example, it started on another node from the cluster. But using the same external IP address, I can connect so that my cluster is already up, the instance is running. I can continue my development process, for example, and I can just create a table in the database that I just created earlier. So everything looks fine. Moving further, in addition to bringing together the best-in-class HA capabilities for SQL Server, Availability Groups is a comprehensive solution offering integrated scaling solutions as well. Let me show you how and highlight the enhancements in SQL Server 2017. With Availability Groups, one or more secondary replicas can be configured to support read-only access to secondary databases. So the client applications running analytics or reporting workloads can directly connect to the secondary databases, or the customer can set up a read-only routing list and connect to the primary that will forward the connections request to each of the secondary replicas from the routing list in a round-robin fashion. We know that these capabilities are not necessarily new to SQL Server 2017, but starting with this version of SQL Server, customers can create availability groups for read scale-out purposes without depending on the cluster infrastructure. But note, this is not a high availability setup, as there is no fabric or orchestrator to monitor and coordinate failure detection and automatic failover. So for users who need HADR capabilities, we recommend they use a cluster manager like Windows Server Failover Cluster on Windows or Pacemaker on Linux. If the read-only clients are spread across various geographic areas, distributed availability groups are the solution in this case. This allows offloading read workloads from the primary replica to readable secondary replicas to sites that are closer to the source of the read workloads. This is not only reducing the utilization of resources on the primary, but also helps with read throughput by reducing network latency and leveraging dedicated resources. For example, a single distributed availability group can have up to 17 readable secondary replicas. And for increased scaling capacity, user can daisy chain multiple availability groups and increase the number of readable replicas even further. Or can also do 2 distributed availability groups from the same availability group for low latency reads in geo-dispersed environments. Let's now talk about the fundamental form of disaster recovery and data protection, which is database backup. We know that no matter what form of HA or DR we implement, database administration best practices recommend taking backups. Accidental or malicious destruction of data can quickly be replicated to all of your environments through pretty much any of the rest of HADR solutions we have mentioned earlier. But using full log backup, you can get point-in-time recovery capabilities that will solve this problem. Another important scenario that database backup enables now with SQL Server being available on a new platform is data migration. If you want to migrate SQL Server databases from one platform to another, one of the recommended techniques is to use SQL Server Backup and Restore. You create a backup of the database on the Windows machine, then transfer the backup file to the target SQL Server Linux machine, and then just restore the backup on the Linux instance. Also, for non-mission critical applications that don't need automatic failover but do require disaster recovery, for example, you can use log shipping for a faster database recovery using the worm standby. More, by setting up log shipping across servers that are running on different platforms, you get protection against platform-level issues. But to manage all these backups, organizations use enterprise-wide solutions from a preferred third-party vendor, usually. These solutions centrally manage all the database backups, take the backups, compress them, ensures with alerting that you are on the schedule, and all those backups are healthy. SQL Server provides an API called Virtual Device Interface that enables independent software vendors to integrate SQL Server into their products by providing support for backup and restore operations. These APIs are engineered to provide maximum reliability and performance and support the full range of SQL Server backup and restore functionality. With VDI support for SQL Server on Linux, our partners can build and run backup software for SQL Server on the new platform. This enables customers to run SQL Server where they want while still being able to leverage their suite of backup tools. We are currently working with a set of backup vendors to build support for their solution for SQL Server on Linux as well. Along the same lines, to create an end-to-end database solution, customers can choose from a wide variety of industry-leading tools. The SQL Server partner ecosystem is well established for Windows-based systems. And in the past year, we worked with our partners to build similar support for Linux as well, for monitoring, backup restore, and HADR. This is just a snapshot of the SQL Server partners resource page that we are building for our customers to find solutions that integrate with SQL Server. These are mostly from backup restore and HADR space, but there are others covering other aspects like monitoring, for example. I was mentioning earlier about the open design for availability groups and detaching it from Windows Server failover cluster dependencies. This enables other clustering vendors like HP or DH2i to integrate their cluster solutions with Service Guard and the Enterprise with both failover cluster instance and availability groups. The goal is to offer customers flexibility in choosing their cluster infrastructure where requirements are different based on existing clustering solutions they already have, or SLAs, features, and price, and so on. Similarly for backup restore. As I was mentioning earlier, we do work with our partners to enable their solutions for all the platforms SQL Server is running on. Thank you for watching this video. I hope you find it useful.
Hi. My name is Jamie Redding, and I'm a program manager on the SQL Server Engineering team. In this session, I'll be discussing the architecture and performance features of SQL Server 2017 on Linux. A little of my background. I spent about 34 years in the computing industry, primarily focusing on systems and database performance. I've been at Microsoft almost 20 years now. I also serve as Microsoft's rep on the TPC, and I'm a member of the TPC steering committee, and I also chair the TPC Technical Advisory Board and the TPC Pricing Committee. In this session, we begin by looking at how we enable SQL Server on Linux and the underlying architecture. Next, we'll discuss several performance features found in SQL Server 2017. We'll also cover some Linux-specific tuning settings that you can use to gain the best performance. And finally, we'll look at some performance numbers and proof points. With SQL Server 2017 on both Windows and Linux, we continue to provide the fastest general-purpose database on the planet. We have consistently demonstrated this performance across both OLTP and analytic workloads. These results were done with close collaboration with our hardware partners and use a suite of TPC benchmarks. But best of all, SQL Server 2017 on Linux is just SQL Server. that enables us to maintain similar levels of performance on both Windows and Linux. We also found some code that had Microsoft features called drawbridge. This was designed for process isolation. We took their code, looked at it, and realized they did some very brilliant work there. They have mapped all the API calls in Windows down to about 50 binary interface calls. So we combine SQL OS and drawbridge into something called the SQL Platform Abstraction Layer, or SQL PAL. So now we can have SQL Server running on top of a very small number of Windows binaries. SQL Server doesn't know any difference and still thinks it's running on top of Windows. So there's no need to write a lot of code. There are a few code paths that are performance critical, like disk and network I/O. For those functions, we wrote more direct code paths to ensure performance. So now we have SQL Server sitting on the PAL, sitting on Linux with minimal code changes. Not only does this performant, it also helps with code quality. Anytime you have to write a bunch of code, the chances of error creeping increases. So the same SQL Server code will run on both Windows and Linux. It's the same version on both platforms. This means when we fix a bug or add a new feature to SQL Server 2017, they appear on both OS platforms. Remember, it is just SQL Server. Now we'll look at a few performance features that are either new or enhanced in SQL Server 2017. We'll look at adaptive query processing, automatic soft NUMA, automatic tuning, column store indexes, the database tuning advisor, and finally, in-memory OLTP. Adaptive query processing is new in SQL Server 2017. It's made up of three components. There is the batch mode memory grant feedback, batch mode adaptive joins, and interleave execution. The batch mode memory grant feedback monitors the memory asks and grants from queries, and if a grant is not correctly sized for the query, performance will suffer. Insufficient memory grants will force the query to spill to temp DB, also hurting performance. If the grants are too high, other concurrent queries will suffer due to wasted memory. When you repeated queries, SQL Server 2017 will track and revise these memory grants to ensure the best performance across the system. The batch mode adaptive join technology allows SQL Server to defer the selection of a hash join or nested loop join until after the first input data has been scanned. Based on the initial scan, the query processor will dynamically change the query plan to use the optimal plan. Workloads with frequent oscillations between small and large join input scans will benefit most from this feature. And finally, we have interleave execution. Part of SQL Server 2017, when a query utilized multi-statement table-valued functions, the number of rows to process was estimated, either 100 for SQL Server 2014 or 1 for SQL Server 2016. These set values could result in the wrong selection of join operators and memory grants, which hurt performance. This feature adjusts the execution plan by executing a part of the query first and then redesigns the query plan on the fly based on the actual number of rows returned. This leads to a much better execution plan and better query performance. Automatic query tuning is an evolution based on the query store we introduced in SQL Server 2016. Automatic tuning is a process that continuously monitors and analyzes your workload to learn its characteristics and identifies the potential issues and improvements. This feature capitalizes on learnings from monitoring databases in the Azure SQL database. This process allows the database to dynamically adapt to your workload by identifying what indexes and plans might improve performance, and conversely, what indexes might be negatively affecting your workload. Automatic query tuning applies the tuning actions that will improve performance. It then monitors the changes to ensure they actually improve performance. If it finds a modification that didn't improve performance, then that change is reverted back to the previous behavior. Part of this process is automatic plan correction. This feature identifies SQL Server query plan choice regressions and then fixes them automatically. Since we keep previous plans, we can force the last known good plan to be used. This feature will also monitor the performance of the forced plan. If the forced plan is not better than the regress plan, the new plan will be unforced and SQL Server will compile a brand new plan for you. If SQL Server verifies the forced plan is better, then that one will be used until recompile is done later. The column store was introduced in SQL Server 2012. Over the releases since then, there have been continual enhancements to this technology. The column store index flips the data out of the traditional row-based storage into a columnar format. Column store indexes are incredibly powerful for decision support and analytics queries that need to scan and aggregate large amounts of data. The column store compresses the data, which reduces the memory and disk footprints. Data can be compressed up to 10x. Column store indexes also filter scans by eliminating row groups and segments that are not needed to satisfy the query, which increases the query performance. the gains of columns or indexes can be experienced with little or no modifications to your queries. Database Tuning Advisor analyzes the workload and how one or more of your databases are set up. Tuning Advisor uses trace files, trace tables, or T-SQL scripts as a workload input. You can create a trace file and trace table workloads by using the tuning template in the SQL Server profile. So after analyzing a workload, the Database Tuning Advisor can make recommendations on changes you can make to the actual physical structure of your database. It will also look at the data statistics that might be required to supplement the physical database structures. These structures are things like additional or modified clustered and non-clustered indexes, indexed views, and data partitioning. The end goal of the recommendations are to reduce the query optimizer's estimated cost of the workload without changing the query at all. In SQL Server 2017, we continue to enhance the in-memory OLTP support. We've added support for computed columns and memory-optimized tables, and the ability to create an index on these columns. This allows transactions to use predicates on these computed columns to improve performance. Though not completely performance-focused, SQL Server 2017 also provides full support for using JSON functions and natively compiled store procedures. We also implemented a cross-applied join with table value functions. So there are some basic starting points for tuning both SQL Server 2017 and the underlying Linux operating system. The same tuning suggestions we use for SQL 2017 on Windows apply to SQL 2017 on Linux. One of the big differences is that when running on Linux, you have more control on how much memory is available for SQL Server 2017 to use. The value is set by using the SQL configuration script msqlconf on Linux. By default, SQL Server is granted 80% of your physical memory on the system. If your system has a large amount of memory installed, that 20% value may be significant, especially the system dedicated to SQL Server. You can increase the amount of memory available to SQL Server by passing a new value to msqlconf. One caveat though, dedicating too much memory to SQL Server can starve other Linux processes. At a bare minimum, you should leave at least 3 to 4 gigabytes of memory for the rest of the system. For the Linux OS itself, you should set the kernel settings for high performance. These may be different depending on the distro Linux you're using. The best practice is to consult with the distro documentation to ensure you have the proper high-performance settings enabled. In addition to kernel settings, we suggest you disable the auto-NUMA balancing on multi-node NUMA systems. This prevents the OS NUMA from conflicting with the SQL Server NUMA balancing. You should also leave transparent huge pages enabled, which allows SQL Server to use large data pages in memory. And finally, if you're running SQL Server 2017 on Linux instead of Linux virtual machine, you should configure a fixed amount of memory to be reserved in the virtual machine. Not doing this will cause significant performance issues. So, how do all these features and tunings relate to the overall performance of the system? Well, we use these tunings and settings to produce several performance proof points throughout the year of 2017. At the Ignite 2017 conference, we showed a video of SQL Server 2017 running on Linux, executing a table scan on a 180 billion row table. The underlying hardware had 480 CPUs, and we were able to drive all the CPUs to 100% and scan the 180 billion rows under 20 seconds. Now, in partnership with HPE, we published 2 separate TPCH benchmarks using SQL 2017 on Linux. The first result was an HPE ProLiant DL3D Gen 9 using Red Hat Enterprise Linux. This result was about 5% faster than a result published on similar hardware using SQL Server 2016 and Windows. This publication really highlights the overall performance benefits in SQL Server 2017. To follow on that result, HPE published another TPCH benchmark using SQL Server 2017 and SUSE Enterprise Linux Server. The unique aspect of this result is that it's a diskless database. HPE utilized their scalable, persistent memory technology. This benchmark had only 2 disks installed, one for the OS and one for SQL backup. This configuration resulted in 45% more performance with a 50% reduction in hardware costs and an 85% reduction in rack space. The details for both results are available on the TPC website at tpc.org. You can also find more information about HPE's scalable persistent memory at hpe.com. We have many more performance proof points and benchmarks scheduled throughout 2018 to further show the power and performance of SQL Server 2017. Thank you.
Hi, my name is Alan Yu, and in today's session, I will be talking about using Linux-based tools with SQL Server. To provide some background, I am a program manager on the SQL Engineering team. I work with engineers on delivering tools such as SSMS, SQL Operations Studio, and CLI tools. Here is an overview of the SQL tools family for DevOps. Our tools can be broken down into 2 main categories: graphical user interface or GUI tools, and command line interface or CLI tools. The goal for GUI tools is to act as your DevOps workbench. Meanwhile, we offer CLI tools for your automation scenarios. All of these tools work well with SQL Server running everywhere. For GUI tools, we have 4 offerings because there are many different scenarios for our users. SSMS and SSDT developers and DBAs mainly use Windows Client as their workspace and need a robust, feature-rich tool. For developers and DBAs using Windows, Linux, or Mac OS for their development environment, we offer SQL Operations Studio, which was recently announced for public preview in November, and the MS SQL extension for VS Code. For our CLI tools, we are making an effort to make these tools cross-platform and open source. I will give more detail about these tools later in this session. In a Windows ecosystem, we have 2 great GUI tools, one of which is SSMS, which is our flagship tool. We continue to have many monthly active users and will continue to be supporting SSMS with new releases every couple months. You can continue to use SSMS to connect to SQL Server hosted on Linux. For our users who are developers and more familiar with Visual Studio, we offer SSDT, which is another Windows-only GUI tool to connect to SQL Server on Linux. This enables developers to quickly query a database without having to load up SSMS. Now, with the release of SQL Server 2017, we want to continue to bring great tools across all platforms to give you choice to interact with SQL Server anywhere. One way is to leverage VS Code, which is a popular cross-platform tool used by developers. We offer the MS SQL extension for VS Code because there are application developers who use VS Code and who occasionally need to query SQL Server for various reasons. The MS SQL extension and VS Code itself are both open source on GitHub, and we would love your feedback and contributions to iterate on this great tool. Meanwhile, SQL Operations Studio targets data developers whose job is mainly managing relational databases and occasionally use applications coding and non-SQL languages. As mentioned before, this tool was released for public preview in November and includes many features such as a management dashboard, a great T-SQL editor with advanced coding features such as auto-suggestions, peak definition, and error diagnostics, and backup and restore dialogues. You can also build your own custom widget to manage the health of your dashboard. Our engineering work is currently all on GitHub, and we are releasing new updates on a monthly release cycle. So please try out SQL Operations Studio today. Now I will be giving a demo of SQL Operations Studio on an Ubuntu 16.04 virtual machine. So currently we have the latest version of SQL Operations Studio, and we can simply open it in our VM by typing SQL ops and then dot. And here we have SQL Operations Studio. And as you can see here, we have our Object Explorer, which you may recognize. And we want to, I guess for the purpose of this demo, we want to create our own custom insight widget based on our own custom query, and then be able to see it in our dashboard. So I'm going to first connect to our local host, which is currently a SQL Server on Linux. And I'm going to connect to it. It also has things such as recent history. And you can also connect to a specific database. And you can also attach it to a server group, such as the production server here. Here, I'll click Connect. And now we are connected to our local host. And let's go look into our databases. And we have 2 databases here. We have our AdventureWorks 2014 and Northwind. And we're going to make our first query on our AdventureWorks database. So I'm going to type my query, do select star, because I want to grab specific column names, but I don't exactly remember what they are. So I'm going to use IntelliSense to help me. So select star from sales. Looks like we have that table. And now we want to grab the tax rate, because we want to try to find the tax rate for different regions. And if we look through here, this is the specific name. So we just press tab, and now we have our query. And this is really helpful, especially for developers who aren't very familiar with the database, to have this type of IntelliSense. So now we're going to execute this query. And you can see here that there's lots of different columns, but the ones that we want to grab in particular is a tax rate. So first we want to have a name, and it looks like that pops up there. And we want to have the tax rate, which we have there. And now let's run it one more time. And now we have this nice format. We have our names and the tax rate for each region. And it might be nice to add a select distinct, just so that there's no overlap. There we go. And now with this results set, or results view, you have several options. You could save it as CSV, JSON, Excel, but we also have this function known as View as Chart. So when we click on here, we have this chart viewer, which has many different chart types that you could actually choose that would best fit your data. But for now, we're going to just use horizontal bar, since this is what we want to see on our dashboard. Now, to add this to our dashboard, we're going to click Create Insight, which will give us this format, which will allow us to save this in our settings. The main thing is that there's this query file that we need to save. So let me go back to our query here in our tab, and let's save this as taxrate.sql. There will be like a replace message, since I did run this before. And now let's update this query file name to this new name, taxrate.sql. Now let's copy this and go into our settings. So let's go to this gear. Another big ask is that our customers really want to have a dark theme in SSMS, and this is a place where you could actually change it to a dark mode for SQL Operations Studio. So it's a nice customer feature to highlight. But first, let's go into our settings. So now we have two views here, and let me actually minimize this here so it's a little bit easier to read. But on the left pane, we have our default settings, which gives us some options to customize our own user settings, such as data source.connection groups, our different connections. And now we have a section for dashboard database.widgets. So this is where we're simply going to just copy over what we saved from our Insight widget before. And copy it here. And now we have updated our user settings. And to just prove that this actually worked, we'll go back to our VentureWorks database, right-click on it, and click Manage. And this is how you access your dashboard. So we click Manage, and there we go. We have a nicely formatted custom widget that will show the names as well as the tax rate for each area. And that concludes our demo for SQL Operations Studio, and we really suggest you to try this tool out yourself. CLI tools are very important to enable continuous integration and continuous deployment. MS SQL Tools, which is SQL CMD and BCP, now runs natively on Windows, Mac OS, and Linux. They are also used for interactive and non-interactive scenarios. MS SQL Scripter is a command line version of Scripting Wizard in SSMS that can dump out schema and data in SQL scripts. It is Python-based and open source, and currently in public preview. Meanwhile, MS SQL CLI is an interactive version of SQL CMD that you execute ad hoc queries with T-SQL IntelliSense in a server's terminal, which typically don't have support for GUI. It includes features such as IntelliSense, syntax highlighting, multi-line querying, and pretty formatting. It is also a great open source collaboration story and is currently in public preview. SQL Package is a tool to deploy database changes and migrate databases between on-prem and cloud. And we are planning to release this soon for public preview for Linux and Mac OS as well. Now, there may be some confusion about the overlap between SQL CMD and MS SQL CLI. SQL CMD is currently our go-to CLI tool for interactive and non-interactive scenarios, especially since it has awesome performance. However, a huge customer ask is that customers feel SQL CMD is lacking in modern interactive features. For example, generally, GUIs are used for interactive scenarios. But let's say if the GUI cannot connect to a server directly due to firewall or security reasons, then it can be difficult to use SQL CMD, since it doesn't have many interactive features such as IntelliSense or syntax highlighting. Thus, we came up with MS SQL CLI by collaborating with the open source community, specifically the DB CLI organization, where our source code is currently hosted today. MS SQL CLI includes smart completion and syntax highlighting, which I will be demoing shortly. In our roadmap, we envision that MS SQL CLI covers both interactive scenarios very well and will eventually cover all automation and non-interactive scenarios that SQL CMD covers as of today. So please try this out. As a note, we will not be deprecating SQL CMD, but we'll just be leaving it alone. SQL CMD will stay in maintenance mode, while MS SQL CLI will receive feature enhancements through GitHub. Now, I'll be giving a demo of MS SQL CLI on an Ubuntu 16.04 virtual machine. Okay, now I'll be demoing MS SQL CLI. And currently, it's already downloaded on my machine, but if you wanted to install it yourself, you could just type in pip install MS SQL CLI, and then you can get the latest version. So to connect to my local host, which is currently a SQL Server on Linux, I will type in MS SQL CLI, and then add -s, which is my server name, which is localhost. And then I'll add my username, which is simply SA. This allows me to put in my password. And looks like we are here. So we have the latest version, and as well as our GitHub. So there's a small little plug if you want to make any contributions or feature requests to check out our GitHub there. And the very first thing I want to show is when you think about SQL CMD, if you used it before, when it displays lots of a table with lots of columns and rows, it's not formatted in a very easy to read format. So first we'll do a command select star from sys, and as you can see, there's already IntelliSense, which is guiding me through this process. So sys.tables. Should take a little bit, and now you could see here that this is the very first record, and we could simply use our arrow key to look up and down. We could use space to skip to the next record. And then you can use Q to eventually exit it. So if you keep pressing space, you could walk through all the records, press Q, and now you're out. But let me just quickly clear my screen. And it just presents data in a lot more prettier format. So next, I'm going to connect to AdventureWorks. And you could already tell that all this IntelliSense is a lot more helpful than what SQL CMD currently provides, which it doesn't provide at all. So we'll connect to AdventureWorks 2014. And what I want to demo here is our multi-line queries. So I'm going to quickly press F3. Let's see if that gives us yes. So let me type select star as the beginning. And if you press enter here, you could basically, what multi-line queries allows you to do is makes your queries in a lot more easier to read format. So I'm going to connect to humanresources.department. And then I'm going to call it as HR because this allows for me to go back up into this query and then query for very specific column names. So if I add HR dot, it displays all the different column names that I could choose in this table. So I'll choose HR.department ID, and let's do let's do group name. And then if you ever want to execute this query, you can add a semicolon, and then it can be executed. And there we go. It's very nicely formatted. We have our department ID and our group name from the human resources.department table. And we're continuing to look for more features to add to MS SQL CLI, and we would love your feedback. Other things that we want to consider is things such as special command, and that will be in the pipeline soon. Oh, and as well as piping itself. Now that we have demoed our main T-SQL editors known as SQL CMD and MS SQL CLI, now I want to talk about more of our CLI tools for data transfer. To start off, we'll start off with BCP, which is mainly used to export and import each table in a BCP format. It's very fast, but it's very complex for handling multiple tables or an entire database. It also can't really recognize relationships well, with such as primary keys and foreign keys. So we brought in a tool known as MS SQL Scripter. And MS SQL Scripter, if you may be familiar with pgdump or MySQL dump, can handle both schema and data. And the main advantage is that it can also handle relationships automatically. So the idea with MS SQL Scripter is that you execute it, and the output is always executable because it produces a T-SQL script instead of simply just dumping out the data. And what you can do with the script is that you can make some small modifications before you actually execute the script. So there's a lot more customizability that you can use with MS SQL Scripter. And it's also open source currently, so you can go to our GitHub and make any contributions or feature requests there. And then finally, we have SQL package. And this mainly uses DACPack and backpack files as its main file format. It can also handle relationships automatically, but it uses the BCP mechanism, so it's a little bit faster than MS SQL Scripter. It's also more portable, and another key advantage with SQL package is that it provides validation time error up front. So let's say that you do have an error, it'll tell you right away, as opposed to MS SQL Scripter, which will give you your error message after it runs a bunch of processes. So this might not matter too much when you execute it in not very long periods of time, but if this is something that's about 20 hours, you would want to have that validation much earlier. However, with SQL package, it doesn't have as much customizability, so that's when you would use MS SQL Scripter. So you may be wondering about other database development tools. And if you have been using JetBrains, Eclipse, DataGrip, etc., and prefer to use those tools for your database development, those tools support SQL Server on Linux, and you can continue to use those tools. In summary, we have a suite of awesome GUI and CLI tools to enable your DevOps and automation scenarios for SQL Server on Linux. If you need a GUI tool on Windows, use SSMS or SSDT. If you are using macOS or Linux, or want to try out something new, try SQL Operations Studio or the MS SQL extension for VS Code. If you need a CLI tool, please use SQL CMD or MS SQL CLI for your T-SQL editing. For moving data, we offer BCP, MS SQL Scripter, and SQL Package. Please try out our tools, especially our new ones in public preview, such as SQL Operations Studio and MS SQL CLI. If you have any feedback or feature requests, please submit them on our GitHub. Thank you.
Hi everybody, my name is Vin Yu, and in this session I'll be talking about SQL Server security, SQL Server agent, monitoring, and troubleshooting. Just to provide a little bit of background, I am a program manager on the SQL Server Engineering team. I am focused on SQL Server on Linux features, developer experiences, and the next version of SQL. As mentioned, in this section we will have 4 subsections. We'll be covering security, agent, monitoring, and troubleshooting. So let's get started with security first. So in this section, there's two agenda items here we want to cover. In the first section, we're going to want to cover some of the security features available on SQL Server Linux, and then cover some of the differences between some of these features on Linux and Windows. Now, if you've been following the news over the last few years, you probably don't need to hear this from me, but today, data security is more important than ever. As companies have more data, the cost of data breaches increases. But because that is with every record, there may be more costs associated with each one. The global cost of data breaches has been estimated to rise more than $2 trillion in the next few years, and these risks are relevant to every company that handles data. Organizations are giving higher and higher priority to data security, and yet data security is still perceived very painful and hard. Which brings us to SQL Server, where our security features are built in right into the product. They are easy to use, require minimum changes to the application code as well. All right. So let's get started about protecting your data first, which is about encrypting your data, whether it be at rest or in transit. SQL Server does have the technologies to encrypt this data no matter where it is. So for example, encryption at rest is a very common requirement for customers who want to protect the data in case the files or disks are stolen. SQL Server enables you to protect your data at rest with varying degrees of granularity with features such as TDE, also known as transparent data encryption, backup encryption, or cell-level encryption. I want to highlight transparent data encryption first because it is so commonly used. This feature encrypts your entire database, the data, the log, and the backup files without requiring any application changes. It works on Linux the same way it does on Windows. The second type of encryption is called encryption transit. This means encrypting your communications with SQL Server using the latest industry standard TLS protocol. Just like on Windows, SQL Server supports TLS 1.2 support on Linux and can be configured to be FIPS compliant. The last type of encryption I would like to call out is the client-side encryption. SQL Server on Linux now supports a feature called Always Encrypted, and here's how it works. Always Encrypted enables you to protect highly sensitive columns of data such as SSNs or other PII data, or even such that even high-privileged database administrators cannot access this data in plain text. This works by encrypting the data on the client side and typically requires minimum changes to your application because our enhanced client drivers such as the ODBC driver or the JDBC driver handles all the encryption and decryption for you. Because the data is encrypted before reaching the database, it's never going to be stored in plain text. Now, so back to our diagram, we just talked about encryption. The next layer of security is about controlling the access, authentication, and authorization. Right. So SQL Server has two types of control features: database access, which controls access by users who connect directly to the database, and application access, control access by end users who connect through an application to the database. Now, on the database side, for example, SQL Server has very granular permission systems, allowing you to control access to specific tables or even individual columns of data. But in particular, I want to highlight, just like on Windows, SQL Server on Linux does support Active Directory authentication. So we'll cover a little bit more of that later on. While features like permissions and AD authentication control access at the database layer, SQL Server also supports several programmability features that make it easier for you to control which data can be accessed through the application layer. For instance, row-level security allows you to control access to specific rows in your table based on the end user. By attaching this logic to the database itself, you simplify your application code and reduce the risk of accidental exposure. Right. Similarly, dynamic data masking allows you to mask query results on the fly according to a centralized policy within the database. For example, you might only want to expose the last 4 digits of an account number or the domain an email address of users in your application. Again, by having SQL Server enforce the masking policy, you simplify your application code and reduce the risk of accidental exposure. So now that we've covered encryption as well as controlling access, let's look at the most outer layer, which is about monitoring access and keeping track of who does what in your database. Just like on Windows, SQL Server supports a fine-grained audit feature, which allows you to track and log activities relating to users, actions, and objects. This feature is commonly used by customers who need an audit trail in order to meet certain compliance standards. So there you have it. That's in a nutshell. That is a tour of all the layers of security in SQL Server. So one thing I'd like to point out here is that SQL Server on Linux supports all the same capabilities as SQL Server on Windows today, as mentioned on this chart. The features in green are the ones that work same across Windows and Linux, so there are no changes there, which brings us to TLS, Transport Layer Security, and Active Directory. There are some differences on how these features are set up, so let's just take a look at how those differences are. All right, so transport layer security differences. So here we're just going to walk through some of the general steps and then point out some of the differences between Windows and Linux. So the first general step to setting up TLS is to obtain a certificate or to generate one. On Windows, this is typically done by using IIS to generate a self-signed cert usually for development and testing purposes, which underlying uses Windows. There are also a bunch of other tools that could be used to generate one of these certs, and on Linux, we would use OpenSSL crypto. Right? Installing these certs on Windows, you would use the Microsoft Management Console. On Linux, we'd be copying and pasting this into the file system. To configure SQL Server to use these certificates, On Windows, you would be using the SQL Server Configuration Manager. And on Linux, we would be using MS SQL Conf, which is a command line tool to set this up, as well as the Linux file system to putting these files where they're supposed to be. So just to highlight, on how to encrypt some things about encrypting connections on Linux using TLS. So not only TLS 1.2 supported, but we are also back-compat supporting 1.0 and 1.1. To use so TLS is used, on the client. You would have to configure your client application to do this. So you would specify encrypt equal true and trust server certificate equals false in the connection string. So as mentioned in the previous slide, this is built on a OpenSSL stack, and it is FIPS compliant. Now, the second feature that I want to point out where there's some differences around setting up Active Directory, is Active Directory authentication. So the general step, I'm just going to list out some of these steps and then point out the difference between Windows and Linux. The first step is you would have to join your SQL Server host to Active Directory domain. On Windows, this is done through your control panel. Okay, on Linux, we would actually require you to use Realm D commands. So this is actually existent in the Realm package. You would actually have to install this separately. The second step is to create an AD user for SQL Server, the SQL Server instance, and set the service principal name. On Windows, this is done automatically by the SQL Server process every time SQL Server boots up. On Linux, you would actually have to configure manually create the AD user on a Windows machine that's connected to the domain controller, right? Or connected on the same domain. And this is done with PowerShell, the PowerShell command new AD user, and running a set SPN binary to get the service principal name set up. So the next step is configuring a SQL Server service key tab. On Windows, again, this is done automatically at the boot up time, so this is not, you don't have to do this. The key tab file contains the service principal and the encrypted keys so that AD users could connect to the SQL Server service. On Linux, this is achieved by using the KT-util tool on Linux and MS SQL Conf to tell SQL Server instance to use that key tab, right? And the last step is to create an AD-based login in T-SQL. This is the same across Windows and Linux. So here we have a simplified diagram where we have the user, the AD controller, and the SQL Server machine. So starting on the user side, once the host has joined the AD domain, the user will need to use the kt init command, which will authenticate the user with the domain controller. As a result, the user will get a key ring, which could be used to connect to other objects in the same Active Directory. Now, on the SQL Server side, once AD account for the SQL Server has been created and the service principal name has been set with the fully qualified domain name of the SQL Server host, we can use the KT-util tool so that we can link the SQL Server instance with the service principal name. The result of using the KT-util tool is that we create a key tab file, which could then be used to accept AD connections. Right? We would then use MS SQL Conf to tell SQL Server, hey, where to look for the key tab file to use. All right. So with that, let's go into a demo where we can show, how to connect to SQL Server on Linux using AD auth. Okay, so currently I am logged into my machine, and what I'm going to do next is log into AD by using kinit. And with that, I have logged in through AD. So now I'm going to try to connect with SQL CMD. So I'm going to use the E flag, which specifies that I want to connect using AD auth. So here you notice that it failed because on the SQL Server instance side, I actually have not set up my key tab for usage yet, right? So the SQL Server instance needs to be linked with the AD service account as well as the SPN, which is done with the KT-util tool. So to save time, I actually already ran the KTutil tool to create the key tab ahead of time. And so let's just take a look at the key tab contents itself. So here I'm looking at the key tab contents itself, and what you do see is that there's two entries in here with the SQL Server service accounts and the SPNs with the fully qualified domain names that I want to connect to. So here you might also notice that there are two entries. There's two entries because there's one for each encryption algorithm that's available. Right. So with that, so now that I have the key tab file, I have to make sure that SQL Server can actually use these files, use the key tab file. So with that, so here I'm just going to copy. So here I'm just going to copy over command so I don't make a typing mistake. So here what I did was I used msqlconf to set the network Kerberos key tab file, and I specified the path of that key tab file. Now I'm going to run restart. So now that at this point, I have the user logged in through AD, as well as having my SQL Server instance configured with AD as well. So let's go back and try to connect. And with that, I was able to connect using AD auth. And that concludes the SQL Server on Linux security overview section. So in this section, we're going to cover agent. So SQL Server Agent is a job execution engine for SQL Server and can be used for jobs on the database or on the data itself. On Linux, this can be managed by SSMS just like on Windows, and the SQL Server service actually runs inside of the SQL Server process, right, on Linux. So some of the common use cases are for maintenance, monitoring, data import, export, or just running anything T-SQL on a periodic basis. It is also used for log shipping, which is a process that takes the logs from a SQL Server database and exports it to a remote server and replays it for a disaster recovery site. So I have two docs on the slide here for you guys to look into, to look at more, to understand how we can use SQL Server on Linux and Agent. And with that, let's go into a demo of using Agent for T-SQL jobs on SQL Server on Linux. All right, so let's get into our demo with SQL Server on Agent. So what I'm going to do here is just create a very simple job of taking a daily backup. So the first thing I'm going to do is create a job called Daily Sample Database Backup. And the first thing I'm going to do is create steps to that job. So here you can see that I'm taking a backup of the database, of my database called sample database here, right? And then I'm also going to create a schedule called daily, where I'm actually setting the schedule to a daily time. Then I'm going to set the daily schedule to this daily job. And then I'm going to add this to the job server. I'm going to apply this to my local job server, and then I'm going to execute this job. So right now you may notice that under SSMS, there are no jobs under my Object Explorer, under SQL Server Agent. So then I'm going to go ahead and just execute all these commands. And here it says that my job called Daily Sample Database Job Backup has been successfully created. Then I'm going to go here and just refresh my Object Explorer. And under SQL Server Agent, we're going to see a daily sample database backup, right? So, you could also monitor agent jobs here with the view job activity monitor. So you can see, I can see the status of, what it's currently doing, when it was last run, if it's enabled, and other metrics about this database job. And that concludes our section on SQL Server Agent. It is very similar to SQL Server Agent on Windows. So going to our next section, we're going to talk about SQL Server monitoring. All right. So this has majority the same. So monitoring SQL Server on Linux is the same experience as it is on SQL Server on Windows. All the DMVs from SQL Server on Windows are also available on SQL Server on Linux. All the third-party tools connecting to a SQL Server instance will continue to work, as most of it just relies on the DMVs. Right. So with all the DMVs available, you can query these DMVs to get the status of your workloads, or continuously query these DMVs to build out a dashboard. So let's see an example of that. Right. So here on my browser, I have a Grafana dashboard. Essentially what this is an entire SQL Server monitoring solution that's built solely on DMVs. Right. So here, this dashboard is an open source dashboard, and I'll explain in a bit how this works, but just browsing all of the information that you can get from a DMV, you can get CPU stats, memory stats, IO stats, as well as information on perf counters. So here I ran at about, in the last few hours, I saw that there was a huge spike in transactions per second and particular write transactions per second. So there's a lot of information that you could gather from DMVs. All right. All right. So what I was and that was the demo I just shown. So just a little bit more about what I just showed you. This Grafana dashboard depends on two other additional components besides Grafana itself, which is just the UI layer. Telegraph, which is an agent, it is continuously querying the SQL Server on Linux environment, and is pushing these metrics into a time series database known as InfluxDB. The data is then just visualized by the Grafana dashboard, which reads the data from InfluxDB and when a Grafana requests it. All right. So, and a little bit more about monitoring itself, we have also been working with our monitoring partners to ensure that they do support monitoring of SQL Server on Linux. Right. So here you can see a few of the partners, and we have a doc link below that talks about as we continue to work with more of our partners to ensure that they do support monitoring SQL Server on Linux. All right. So which leads into our next section on troubleshooting. All right. So when we talk about troubleshooting in this section, we're not talking about troubleshooting of your T-SQL workload. What we're really focused on is, hey, what does SQL Server look like on Linux, on a Linux operating system? So here are some of the questions which walks us through a path of how we're going to approach troubleshooting from the Linux system. Right? So we're going to cover some topics such as what does SQL Server look like from the perspective of my system, how do I manage the service, how do I start it, what happens when SQL Server stops, where do I start looking at it, how to resolve network issues, as it is a very common issue, as well as what tools can I use to gather for the diagnostics so I can use it for troubleshooting. So what does SQL Server look like from the perspective of my system? If you use top, this is a utility that comes with most Linux systems, for sure on Red Hat, and as well as Ubuntu and SUSE, which are the three distros that SQL Server supports on Linux today. So when you type in top in your console, what you're going to get is an output that's very similar to what you see on the slide here. And you can see that it looks very similar to the task manager of Windows, right? So here you can see, how much CPU is being consumed by each process and how much memory is being consumed by each process, and you can sort it in either way. And this is all achievable. This is all available in the command line. Right? So if you were just SSHing into your SQL Server on Linux, you could grab this view, right? So now that we know what SQL Server looks like from the perspective of my operating system, let's learn about how we manage this a little bit. So as you may have seen in one of the previous sections of today, systemctl is the utility that we use to start SQL Server, to stop SQL Server, to check its status, as well as restart the server, right? And so when I do run a systemctl status on MS SQL Server, this is what you're going to see. You're going to see it being active or inactive, depending on the current state of your SQL Server. And one thing to notice here is that we have two PIDs. One of them is actually the parent thread, and the other one is the child thread. The parent thread is actually responsible for launching the actual SQL Server instance. Other responsibilities of the parent thread is to monitor it and to make sure that there's nothing going wrong with it. Right. So one of them is the parent, is essentially a launcher of the SQL Server instance. So SQL Server is launched and managed by a, so we talked about systemctl, right? So what's actually launching it? What's actually calling underneath it, right? So SQL Server is launched and managed by systemd, which is a service manager for Linux operating systems. So for each service, there is typically for each service that's managed by systemd, there's typically a systemd unit configuration file. So SQL Server is no different. There is a unit configuration file located in this directory of under user, library, systemd system called MSSQL Server, mssqlserver.service. So if you were to take a look at the contents of this file, first of all, this file defines how SQL Server should be managed at startup by the system, as well as some of the limits that we put in there by default. So for example, when looking at this file, what you may notice is that, hey, there's a service component of this file, and it's an exec start. Essentially, the binary of SQL Server is at this directory. So opt MSSQL binary or bin SQL Server, right? And there's some other configurations that we also place in this file. For example, if SQL Server started and shut down and start and shut down too frequently, that may cause problems. So by default, we make sure we put a throttle on this such that you cannot restart your SQL Server instance more than 3 times in 2 minutes. Now, if you change this unit file, then it will change the way SQL Server is managed by systemd, right? So where can you get more? Where can I get more information about the SQL Server service? So we talked about, now at this point we know how SQL Server is managed and run, right? One thing you might ask is, well, how do I get more information about SQL Server as it's running, right? What logs are there on the Linux system? One tool that you could use is journalctl and journald, right? So by running journald, essentially what this is most of the applications that are configured by systemd will also take in logs from the applications or services that it is managing. So in this case, I'm running journalctl and I'm specifying the name of the service with the .u flag. And here you can see a timestamp, the user, as well as the name of the processee, and whatever the processee or service is spitting out to to the journals. Right. So the next step, the next common troubleshooting is, we have a lot of customers or users that might say, hey, SQL Server stopped, won't start, hangs, where do I start? The first place that we tell most of our customers to go to and users is that to look at the log directory, which is available under var opt MSSQL log directory. And here you're going to find a few types of files. I'm going to go over these files and what they mean. Right. So here there's an error log file. An error log file is generated every single time SQL Server is restarted or started. Right. And so there's also a set of core server files. These are core dump files, essentially, that are generated automatically by the parent process when SQL Server crashes. So as mentioned earlier, SQL Server, there are two PIDs, two processes. One of them is a parent process, the other one's a child process. The parent process will actually trigger a core dump if they find that there's something wrong with the SQL Server engine, right? So here there are other logs, which are default traces enabled by SQL Server. And there are also system health, and hackathon related log files as well. Right. So if you were to take a look at some of the files in this directory, here, for an example, we're going to see that there are a few core dump files. there's several error log files, and the error log without the new number attached to it, this is the most recent error log file. Right, so this is the most recent started instance of SQL Server. And one thing that we do that our customer support team may ask our end users to do is to generate the dump manually. So let's say there's something wrong with SQL Server, both the parent process and the child process is hung for whatever reason, or you're getting to a point where there's something really wrong with SQL Server. Our customer support team may ask you to manually generate a dump. And this could be very useful for us to troubleshoot what's wrong in your environment or in our customer's environment. So the usage of this is, there is a script called handle crash. All right. So in here you would specify the program name, the process ID, which is the process ID of the engine and not the parent itself, because that's the dump we want to generate for. The program directory, dump directory, of where you want to dump it, the instance ID, and the crash ID, and whether you want to kill the process shortly after or you don't. Right, and here's an example of what that might look like. So up to this point, we talked about, hey, how can we troubleshoot SQL Server by looking at some of its logs and how SQL Server is started by the system. Well, what if we want to monitor SQL Server proactively? So as mentioned in one of our previous slides discussing how SQL Server is started in the configuration unit file, you can also call that binary directly by launching opt msql bin SQL Server, which launches this in the foreground, right? So this is really good for dev test scenarios and real-time use cases. Another common area of troubleshooting to make sure that you could connect to your SQL Server is to ensure that you resolve all the network issues for SQL Server. These are some of the general checks that we recommend you check if you are running into any network related issues, such that at this point you could run systemctl status on SQL Server and you know that it's running, but as an end user or from an application perspective, you cannot connect. Right. So the first thing we ask that you check is that you're connected to the correct instance and host. The second is to ensure that you have opened up the SQL Server port, and by default this is 1433, but if you have configured SQL Server to listen to a different port, just remember that you do have to open the firewall on your OS as well. Right. And also, if you are running on a public cloud such as Azure, make sure that the network interface on your cloud is also opened to allow connections coming in. All right. So one way we could check which port SQL Server is listening to is actually to look at the error log file. When SQL Server is starting up, it actually prints out which port it is listening to. So in this case, we're listening to 1433. 1434, which is for administrative connections, and 5022, which I'm using for HA, right? So, and because there are multiple error logs, we want to look at the most recent value because this is the one that has the current status of which port SQL Server is listening to, right? And to add a firewall rule, we would use on RHEL, we would use a firewall CMD, and this command at the very top here, and this would add the port to open up the port for allowing access into SQL Server. Right. So there are also some other tools. I mean, these are not all the tools that are available that you can use to troubleshoot SQL Server on Linux, but PSS-Diag is a general purpose tool that's created by Microsoft, and that allows us to collect various logs and data files on your system. PSS-Diag can natively collect system monitor logs, SQL Server telemetry, as well as a bunch of other types of log files on your system, a bunch of other files that's on your system. So this is actually used by our customer support team to troubleshoot all the issues, and there's a link here if you want to learn more, as this is an advanced topic. And that wraps up our monitoring and troubleshooting session. Thank you.
Hi, I'm Mihaela Blenda, Program Manager on the SQL Server team. In this module, I'm going to talk about what are the options to run your SQL Server on Linux workloads in cloud. To provide some background, I'm a senior program manager on the SQL Server engineering team. In that position, I focus on SQL running in Azure VMs, as well as high availability and disaster recovery scenarios for SQL Server. After a little more than just 1 year, a new release of SQL Server is now available on obviously Windows, and for the first time ever on other platforms like Linux and Docker. This release will enable you to run Linux applications on the database with industry-leading performance for all your workloads. And on top of being a performant and reliable software, SQL Server 2017 offers an industry-leading security toolkit, built-in AI, graph capabilities, and query performance with adaptive query processing. In addition to in-memory across all these workloads, we can also deliver these capabilities with a consistent experience, both on premises and cloud, across all editions with common development and management tools and common T-SQL. And our goal is to provide you with a great experience with data, no matter where you choose to implement it. So all these capabilities are now available on the platform of your choice. SQL Server 2017 can run on Windows, of course, but also on various Linux distros, Red Hat Enterprise Linux, Ubuntu from Canonical, as well as SUSE's Enterprise Linux. But you can run it in many other distros as well. And even more, with Docker support, you can run SQL Server on a lot more platforms like Kubernetes and Docker Swarm, Mesosphere, DCOS, or Pivotal. And as I mentioned earlier, our goal is to get SQL Server everywhere and let customers run wherever they choose to. On top of a comprehensive set of features and flexibility of the programming languages, customers need flexibility when it comes to the choice of underlying infrastructure as well. This includes both the underlying operating system as well as the platform. In addition to Azure, you can run SQL Server on pretty much any public or private cloud hoster that has Linux offerings. Some of them, like AWS, started to offer built-in images with SQL Server on Linux. More precisely, they have SQL Server on Red Hat in AWS's case. We are going to continue working with our partners to enable similar offerings for their hosted services as well. Also, with Azure Stack, you have the option of choosing from a broad range of built-in images covering multiple server versions, editions, as well as operating systems, including images with SQL Server 2017 on Ubuntu and SLAS. In terms of deployment options that you have in Microsoft Cloud, Azure Gallery offers SQL Server built-in images on both Windows and Linux, all SKUs, covering all versions starting with SQL Server 2008 R2 onwards, including the latest SQL Server version we've just released, SQL Server 2017. These images are constantly refreshed with the latest security and other operating system patches, as well as latest updates for SQL Server. One thing to highlight is that Azure is the only cloud that offers Developers Queue to get you started on your development or testing environment at no cost for SQL Server, from SQL Server perspective. In terms of VM sizes, you have multiple options as well. This includes options for CPU-intensive workloads with the G-series VMs, or memory-optimized VMs with M-series for workloads that use in-memory or column store capabilities. Also, latest versions of the most popular VM sizes include options which constrain the virtual CPU count to 1/2 or 1/4 of the original VM size. These are ideal for database workloads that are not CPU intensive, but need to maintain the same memory, storage, and I/O bandwidth characteristics. With these new size options, the licensing charge for SQL Server will be constrained to the new virtual CPU count, resulting in maximization of the available resources, at a fraction of the per core licensing cost for SQL Server. Let's see how easy it is to bootstrap a SQL Server virtual machine in Azure. I'm going to show you how to spin up a SQL Server instance using a built-in image with SQL Server on Red Hat Enterprise Server. Okay, so let's just go to the Azure portal, and we're going to start the workflow to create a VM based on a built-in image with SQL Server 2017. We're going to choose a developer edition in this case. So as I was mentioning earlier, you can find in the gallery the broad range of SQL Server built-in images, all SKUs, all operating systems, and all the versions that we support. In this case, we chose Red Hat Enterprise Server. And next, we're going to go through the layers that will configure the SQL Server VM. So we're just going to name our VM. We're going to provide the credentials that we're going to use later to connect to the VM. So the username and the password. And we're also going to provide a resource group that our SQL Server VM is going to be created in. Next blade, you have the option to choose one of the available VM sizes that our Azure infrastructure provides. You have multiple options here. These are just the defaults. But if we go and click on View All, I want to show you the constrained sizes VMs that I was mentioning earlier and how do they show up. So let's search for them. So for example, we have this E series, right? As you can see, we have the same configuration in terms of memory and disks, but for the virtual CPUs, we have a half size and a quarter size option. We're just going to go with this smaller size VM in this case. And the next blade, you can configure other options for the VM. I'm going to configure the network security group and include the inbound rules so we can connect from outside Azure to the port 1433, so to the default port for connecting to SQL Server. And another nice option is to save some money on the VM. We can schedule, for example, an auto shutdown when I don't need it anymore, or during nighttime, I can schedule a shutdown of my VM, and I will not incur any charges. So at the end, I confirm and I click Create, and the deployment of the VM is triggered. And we can actually monitor it, or we can just go to the virtual machine, and in a few minutes, I will have the VM. We can look at the options after it's created. We can look at the configurations. What we will need is the public IP address so we can connect it. In this case, I'm just going to use the Cloud Shell to connect to SSH into the VM. So we're going to use the IP that we copied earlier. And these are the credentials that we configured when we created the VM. And a couple of more things to do before we can actually connect to the SQL Server running in the VM. One is to open the firewall from within the machine as well for port 1433, so it can connect to SQL Server. So we just have to do that. And again, the password for the sudo user. And another thing, the next thing that we're going to do after this command finishes with success, that's fine, is to set the password for the SQL Server SA account. So when we built the base image for these VMs, we used a secure random password. So now in order for you to connect to it, you'll have to reset the password so you actually know it. right? So in order to reset the password, we'll have to stop the SQL Server service that is running, and then use MS SQL Conf tool to set a new SA password for the instance. Okay, we confirm it, and then we wait for the command to finish. We stop. We will have to start SQL Server. Back. Yeah, and now we're ready to connect it. In order to connect, we can see that it's running now, right? So everything looks fine. So in order to connect, we're going to use the new Operations Studio interface. So we provide the SQL as a server name. We provide the IP that we just used to connect to the VM, the SQL credentials, the password that we just reset, and we're ready to go. We should connect now. Yeah, everything looks fine, and I can start my development process, right? I can create a database, and I'm ready to go. So that was a demo. Thank you for watching this video. I hope you find it useful.
Hi, welcome to the Futures of SQL Server on Linux session. My name is Uma Chandar. I'm a program manager in the SQL Server team. My focus areas are SQL Server on Linux, Polybase, and machine learning services in SQL Server. Today, I'm going to talk to you about the future features in the vNext of SQL Server on Linux. A caveat with this session is that all the items in this session may change in the future, since we are not done with our planning, so please keep that in mind. Okay, so the first area we are looking at for investment in Linux is what we call a SQL Server as a data hub. Today, you can use Polybase and link servers on Windows to get to data external to SQL Server. Now, with the new connectors, which we will ship in the vNext of SQL Server, you can now have native connectivity to Oracle, Teradata, MongoDB, and other data sources. So this, out of the box, will provide functionality from Linux to talk to external data sources through Polybase. So this is one of the big investment areas for us, both on Windows and Linux in SQL Server vNext. Now, the next feature area that we are looking at is machine learning services on Linux. As you know, we added machine learning services support in SQL Server 2016. And in 2017, we extended it to support Python. So now for vNext, we are bringing the support from Windows over to Linux. So you can run now your R and Python scripts in SQL Server. Along with this, we are also looking at extending the in-database package management to support both R and Python packages. This feature will allow you to store the packages in the database and have it installed automatically when you execute your scripts. So this is functionality which will provide parity with the Windows environment and the Windows features, and we are excited to bring this over to Linux. And lastly, I have a list of features which we are investing for vNext based on customer feedback and many of the lab engagements which we have done here. So the first feature in the area of security is enabling support for Linux accounts, so that just like on Windows where you can connect to SQL Server without a password, you can now log in and do the same on your Linux machine or your Mac desktop. So this is a feature which will give you ability to use your local Linux accounts as logins in SQL Server. The second area which we're looking at in terms of security is the Active Directory support. So here, this is more about extending and working with the vendors who provide many solutions on Windows and have them certify their applications on top of SQL Server to work on Linux also. So this is something we've heard as feedback from our customers, and we're looking at how to address that for vNext. The next item which we're looking at is the replication support on Linux. So this will allow you to use SQL Server on Linux as a subscriber or a distributor on Linux. And we'll also bring the rest of the functionality which you're using on Windows to Linux. And lastly, the area of distributed transactions. So we've had feedback from customers where they have applications which do a distributed transaction between SQL Server and other data sources, or even between SQL Server and other SQL Server instances. So now we are looking at enabling the distributed transaction support for such multi-database, multi-instance transactions. Okay, so with that, I hope you enjoyed the course on SQL Server on Linux. You also got an idea of how to use SQL Server with containers. I'm sure you're excited about the HA features on Linux and how to get the best performance out of the platform and so on. And the last session here was about the futures of SQL Server on Linux, just to give you an idea of where we are investing and what are some of the features you will see in the upcoming CTP. Thank you very much.